Respected dignitaries, welcome to our presentation based on Safe Vehicle Transportation System. So this is the outline of our project. Now starting with the introduction part. So most of the road accidents which are occurring in day-to-day life are due to certain number of factors. Few of those are careless driving, drowsiness, or due to fog. The main concept of this project is to prevent such road accidents and provide immediate treatment to those road accident victims by using IT-based sensors. So in this literature reviews section, the first paper was based on sending the accident information through wave to the hospital. The second paper was based on the detection of vehicles under fog. And the third paper was based on detection of eye blink rate of eyes by use of IR sensor. So as of now, there are no such technologies to reduce such road accidents and to rescue the victim immediately. So this project will prevent such more accidents and reduce the loss of life due to those accidents. The certain number of problems formulated are delay in providing help to the accident victims, low visibility due to dense fog, and accident due to careless driving. In this methodology section, so a LCD screen will be placed on the car dashboard. The driver will be able to see the state of drowsiness and the engine temperature via the use of LM35 temperature sensor, which will be installed in the engine, and the IR sensor, which will be installed in the spectacles. This is the flowchart of the car dashboard. So the LM35 sensor installed on the car engine basically detects the temperature and gives the required output as by glowing the green LED or the red LED according to the value it detects. Similarly, the IR sensor also detects the blink rate and give the desired output. So this is the engine operating monitoring. If the temperature is 195 to 220 degree Fahrenheit, then the driver is not notified. If it is beyond or less than the optimum range, then the driver is notified by the red LED placed on the car dashboard. Eye blink detection. Here, an IR sensor is used, which is used to detect the blink rate of the eyes. An IR sensor has a transmitter and a receiver, so the IR ray is illuminated on the eyes. When eyes are closed, an active high signal is received by the IR receiver. Also, when the eyes are open, active low signal is received by the IR receiver. So, when the active high signal sustains for more than 1 second, the eyelids are considered to be closed for that period of time. Therefore, the driver is considered to be drowsy and an alert is given.
So this is the smart street light system for vehicle detection in fog. Here ultrasonic sensor along with one green LED and one red LED is installed in each of the street lights. The ultrasonic sensor is used to detect the vehicles in the presence of fog, and the green and the red LEDs is used to convey the information that whether a vehicle is present or not in the presence of fog. So this is the basic model. Now we move on to the working of this model. So here the ultrasonic sensor works by using the sound waves. The emitter of the ultrasonic sensor emits a ray of sound, and that ray of sound bounces off from one obstacle and enters into the receiver. The ultrasonic sensor is able to detect any obstacle that is present in front of it. The ultrasonic sensors are mounted horizontally on the street lights. Whenever the ultrasonic sensor detects any vehicle, the red LED starts glowing, giving an alert that there is a presence of vehicle in front of that particular street light. If the ultrasonic sensor present in a particular street light is not able to detect a vehicle, then the green LED is glowed to give the alert that there is no vehicle present in front of that particular street light. Now a driver coming away from a far end will already get to know or will already be alerted by looking at the green LEDs or the red LEDs that are glowing on the street lights. So in the presence of fog, a driver coming from a far end will not be able to see the vehicle present in front of him, but will know that whether a vehicle is present in front of him or not by looking at the green or the red LEDs glowing in that particular street light. Now the range of the ultrasonic sensor is designed such that its range is same as the width of the road, so that it helps us to detect the vehicles accurately. Therefore, the smart streetlight system has been summarized by this flowchart. Here, if the ultrasonic sensor detects a vehicle, green LED glows, and if the ultrasonic sensor doesn't detect a vehicle, red LED glows, and therefore the driver is alerted that whether a vehicle is present or not in the presence of fog.
Our third part is the accident detection and rescue system, and the main motive of this part is to detect the accident and notify the authorities. So first of all, we will detect accident. To detect the accident, accelerometer sensor is installed in the car used to detect the accident impact. Whenever there is an accident impact, there is an abrupt dynamic change caused in the acceleration of the vehicle. Such acceleration forces are detected by the accelerometer. The accelerometer has a capacitor whose value changes when any sort of acceleration in the vehicle happens. This change in the value is then sent to the microcontroller, which takes decision according to the input from the accelerometer. The acceleration, that is g-force, is converted in the term of small g, that is acceleration due to gravity, by dividing the value by 9.8. When g-force value exceeds the threshold value, it is considered that the accident is detected. In the threshold of g-force for accident detection table, for the first case, no accident happens when if the car is traveling at a normal speed, then acceleration is found to be negligible. Therefore, accelerometer does not change in acceleration, or if change, it is minor, that is 0 to 4g. So therefore, it is concluded that accident did not occur. For the second case, mild accident, the G value will vary from 4 to 20 G, and for the medium accident, the G value will vary from 20 to 40 G, and for the severe accident, the value will be above 40 G, that is, we can call it 40 plus G. So after detecting the accident, our next motive is to rescue the victim. In the rescue part, the information of the victim and his car is sent to the web page. The web page is designed in HTML. The use of NodeMCU microcontroller enables us to synchronize the HTML created web page along with the hardware components. The web page can be accessed with the local IP address that is generated by the microcontroller. The healthcare facilities can use the web page information in the rescue process. Flowchart of the accident detection and rescue system. So here is an accelerometer sensor is installed in the car to detect the accident impact. So if the g-force value is less than the threshold value, that is 4g, the green LED will glow. That means it's significant that the system is okay. And if the g-force value is greater than the threshold value, that is 40g, the buzzer will buzz and red LED will glow to alert the driver that accident is occurred, and the car number and the location is sent to the cloud database, and the nearest hospital and the police station can access the database. This is the block diagram of our project. The microcontroller is connected with the vehicle, ultrasonic sensor in the street, and the LCD display and the local server which is connected with the cloud. Inside the vehicle there is a IR sensor, a LM35 sensor, that is temperature sensor, and an accelerometer sensor for the accident detection. In this project we are using this hardware components, Arduino Uno, NodeMCU, LCD, buzzer, IR sensor, accelerometer sensor, ultrasonic sensor. The software components are Arduino IDE and Tinkercad simulation.
Here, an LCD display, an IR sensor, and a temperature sensor is connected to the Arduino board. So, you can see in the LCD display that the temperature is optimum, which is 195 degree Fahrenheit to 220 degree Fahrenheit. Also, 90 degrees Celsius to 104 degrees Celsius. You can see the LED is not glowing and the buzzer is not buzzing. Now, if we increase the value, that is the value of the temperature beyond the optimum level, let's say 150 degree Celsius, you can see in the LCD display, it is showing that the temperature is not optimum, and also the LED is glowing and the buzzer is buzzing. Also in the serial motor, the temperature showing to be not optimum. Now, if we decrease the value below the optimum level, then let's say the value of the temperature to be 80 degree Celsius. You can see in the LCD display that the temperature is not optimum. The buzzer is buzzing and the LED is glowing. Also, in the serial motor, you can see that the temperature is shown to be below optimum level. So, closed eye gives an active high signal. So, when an eye is closed for more than 1 second, drowsiness is detected. Now, we simulate the sensor so that it can give active high signal for more than 1 second. Hence, we can see in the LCD that the eye blink shows drowsy, and also LED glows and the buzzer buzzes.
This smart streetlight system has been designed to detect the vehicles in the presence of fog to eliminate the possibility of accidents. So now let us take a closer look at the circuit. Here we can see there are two ultrasonic sensors, and each of the ultrasonic sensor is placed or installed in each of the streetlights. So the first ultrasonic sensor along with the two LEDs represent the first street light, and the second ultrasonic sensor along with the two LEDs represent the second street light. Now green LED represents that there is no vehicle present in front of it, and red LED represents that there is a presence of vehicle in front of the ultrasonic sensor. And now we start the simulation. Now as we can see, when the vehicle or the green ball that demonstrates the vehicle in this case is coming in front of the first street light, the red light present in the first street light starts glowing, and the notification on the LCD board is displayed that is your car is at first street light. Now I remove the vehicle from the first street light. Now suppose let us take a look at the second street light. If I place the vehicle inside the second street light, the second street light the red LED present in the second street light goes red, and therefore the LCD display also displays.
This is the circuit of accident detection and rescue system, consisting of an accelerometer, a buzzer, and a LCD display connected to a Arduino Uno board. Now we will run our Arduino code in the simulation. As we can see that no acceleration is detected by the accelerometer, so buzzer remain off, and in the LCD accident status is showing not detected. Now we have increased the acceleration more than 4g. As soon as acceleration value get increased more than 4g, accelerometer detects accident, and in the LCD display accident status starts showing accident detected, and also buzzer start buzzing. After buzzer start buzzing, updates sent to the web page start appearing in the serial monitor. We have written the code of HTML in the Arduino IDE software to generate local IP address to create a web page. In the serial monitor, IP address is generated, so from here we copy the IP address and paste it in the Google search engine. As soon as we enter the IP address in the search engine, the web page gets created, which consists of information about the crash car. The web page can be accessed by the authorities with the local IP address that is generated by the microcontroller to rescue the victim.
This work includes all the aspects of safety that will reduce the number of road accidents and also the number of deaths in accident. And if by any means any accident occurs, it also includes a rescue system that will send the details about the car that has undergone accident to the web server, so that that particular victim can be rescued. In future work, we can track the ambulance and control traffic for ambulance so that it can move fast and carry the victim to the respective hospital, and other safety measures can be opted. Few other advanced use of sensors such as alcohol sensor to detect if the driver is under the influence of alcohol or not can be used. So this is the Gantt chart. It shows the division of the work that has been done through the entire year. In the first 6 months, literature review and the theoretical background of the sensor and the testing of the sensors were done. And in the next phase, the hardware implementation and the designing of the thesis was done. These are the few references that helped us in this project. Thank you.